Hello, we are working with polynomials. And so let me share my screen. All right, these are some notes. All right, so we're dealing with exponents and polynomials. So basically, when we're dealing with a polynomial, we are still working with the algebraic expression, okay? And is of the form ax to the n power, where a is any real number and n is an integer that is greater than or equal to 0. So basically, you can't have an exponent that's a fraction, okay? Can't have a rational exponent. You can't have a exponent in your denominator, okay? So if it doesn't fit that form, it's not a polynomial, it's just an algebraic expression. So the different classifications of your polynomial, you have monomial, mono meaning one term. Those are some examples in that column. And then you have binomial, bi meaning two, so two terms. And then you have trinomials. And then there's some other classifications, but those are the three main classifications of your polynomials. All right, so we have 1, 2, and 3 terms we'll be dealing with. And the operations with polynomials will add, subtract, multiply, and divide. And you will be doing evaluating. And so you've already dealt with evaluations of algebraic expressions and applying an order of operations. So the same will apply here. All right, so let's look at, you have 2 homework sets for chapter 5, dealing with the exponents and polynomials. The beginning, which we've covered some of it. You're adding, subtracting, and evaluating. So let me just go over the more application part. And so when we have to find the perimeter of a rectangle, you have to ask yourself, what is the perimeter? Okay, perimeter is just walking around the outside. Okay, so dealing with the outside. Area deals with the inside. So perimeter, you just add up all the sides. Basically, in this problem here, there are perimeter formulas for the rectangle. Again, the perimeter of a rectangle is twice the length plus twice the width. And again, that's the same as adding all the sides. So that means if this length is 3x squared plus 4x plus 1, then this is also 3x squared plus 4x plus 1. If this is x plus 8, this is also x plus 8. So in other words, it's like we are just adding the sides. And notice how I lined up like terms together, okay? And like terms, what I mean by like terms, they have the same variable and exponent part. All right, and then we have x plus 8 and another x plus 8. So this is almost like twice the width plus twice the length plus twice the width. So same thing, just adding the sides. And so when you do that, 16, 17, 18. And then we have what? 4x. 4x is 8x, 9, 10, 10x. And then we have the 6x squared. Now notice that when you are adding or subtracting polynomials, the exponent does not change, okay? Only the coefficient. The coefficient is a number that's attached to your variable or the constant, okay? And so this would be your final answer, 6x squared plus 10x plus 18. And this is in descending order. And what I mean by descending order, I mean looking at the exponent, okay? Highest degree, then next highest, and the constant is last. All right, so that is, we dealt with the adding polynomials. All right, so you do have some more application, and this is dealing with the triangle. So let me just, the first part is dealing with the perimeter. I want you to find the perimeter of the triangle, okay? Let's put that on the board. And again, you just add up all the sides to get the perimeter. And this is how you get the 22y plus 7t. You add them up. So you have 5y plus 15y is 20 plus 2y is 22y. And then you have plus 5, positive 5t, and negative 5t cancel. and you're left with 17. So that's the perimeter. Now the problem, the work is when you have to find the degree measures of the angles of the triangle. Now they will tell you in the question help that the sum of the angles is 180 degrees. So that means that you would form your linear equation here. 6x minus 3 plus 2x minus 1 plus 5x plus 2 is equal to 180. Okay? All right, so we got angle 1 plus angle 2 plus angle 3, or the measure of, is equal to 180. So this is your linear equation to solve. Okay, combine like terms. Again, we have 6x and 5x and 2x. So that's 7 and 5, which is 12x. And then we have the negative 3 and the negative 1 and the positive 2. That gives you negative 2 is equal to 180 degrees. So let's see how that shortens it for you. And then go through the process. Add 2. Oh, this is 13. This 8 and 5 is 13. Okay. Because that's 8 and 5, yes, 13 and 12. All right, so we have 13x is equal to 182. Make sure I have that, okay. And then divide by 13. All right, and so x is equal to 14. All right, so once we have x is equal to 14, you can find the angle measures because we now know what x is. So for example, when you have 2x minus 1, we can evaluate this expression because we know that x is 14. So we place the x with 14, okay? And so 2 times 14, that's 28, minus 1 is 27. So that's how we get to 27, okay? And then you do the same thing for this angle. Plug in 14 for x. So that's 5 times 14, and then plus 2. So 5 times 14, 70 plus 2 is 72. Okay, so that's where you get this. Now to get the third angle, again, you can just substitute for the x, okay? For 6 times 14 minus 3, and it should give you 81. Or you can add these two here, okay? You get 99 and subtract that from 180 because all three together should give you 180. So that's where the 81 is coming from. So these are your three angles, 27, 81, 72. The sum of those angles should equal to 180. All right, get into your laws of your exponents. So I do have all right, so your laws of your exponents. Again, you have your product rule. You add the exponents of your like bases. Now understand your like base are the x's, okay? So when you're multiplying like bases, you add the exponents. So for example, 8 to the 5th plus times 8 to the 6th, and that will be 8 to the 5 plus 6, which is 8 to the 11th. Base stays the same, you just add the exponents. Quotient rule, you subtract the exponents. And so I gave you two scenarios. Scenario 1 is when the top exponent is greater than the bottom. Scenario 2 is when the bottom exponent is greater than the top. So you get two different outcomes here. So when the top is greater than the bottom, then you don't have to worry about getting a negative exponent. However, when the bottom is greater than the top, then depending on how you work it, you may get a negative exponent. Okay, so if I have x to the 2nd over x to the 5th, you may say x to the 2 minus 5, which gives you x to the negative 3. And normally they want it written with a positive exponent. So we have to give you the negative exponent rule, which says that x to the negative n is equal to 1 over x to the positive n. So basically what it's saying, if you have a negative exponent at the top, then it goes to the bottom and becomes positive. Okay, the base and the exponent change locations. Okay, and the signs change. The sign of the exponent changes. All right, so for example, x to the negative 3 actually becomes 1 over x to the 3. So it's at the top, so we go to the bottom and it becomes positive. If it was at the bottom, a negative, then it would go to the top and become positive. Then you have the power of a power rule. And basically what that's saying, you multiply the exponent. The base stays the same. And so it will be x to the n times m. Okay. All right. And so an example there, if you have x squared y raised to the third. Well, in here we can see that the x is squared and the y, we don't see an exponent, but we can put a 1. So we have to multiply the 3 by each of these exponents. So that becomes x to the 6, y to the 3. Okay. Good. And then the 0 power rule, x to the 0 power is equal to 1. Good. Just remember that the degree of any constant is equal to 0, because when you find the degree of a polynomial, we're looking at the exponent of the variable part. Okay. And so when you just have a constant, you don't see a variable part. So there's like an invisible variable to the 0 power. Okay. So the degree would be 0 if we're looking at the variable part. All right, good. All right, so let's look at some examples. All right, so here we had x to the 6 times x to the 5th. We just did that one. You add the exponents, you get 8 to the 11th. Here, numbers you treat as numbers. So -9 times -8 is 72. And then you have x to the 7th times x to the 7th, which is your 14. So you would have a positive 72, and then x, and then raise that to the 14th. You add the exponents. Good. This is your power of a power. We said power of power, you multiply. So 2 times 4, which would be 8. So that's n to the 8th power. All right, again, we did that one. That one. All right, so let's look at this one. Let's do a similar exercise. All right. And so this one will incorporate 2 of your laws here. And so you have an exponent here and here. Now, it may help you to write out, so that's 5 to the 1st power, x squared, y to the 3rd, z to the 1st, and that's all raised to the 2nd. And then times x to the 2nd, y to the 1st, raised to the 5th. So you're going to multiply the 2 by each of those exponents, and then multiply 5 by each of these exponents. So the base doesn't change. So we have 5 squared, x to the 4, y to the 6, z squared. And then here, x to the 10th, y to the 5th. Now, looking here, this is all multiplication. You have like bases. Okay, we have x and x. Now, notice also that we have 5 squared. 5 squared is a small number. So since 5 squared is a small number, you can go ahead and simplify that. 5 squared means 5 times 5, so you get 25. And then x to the 4th times x to the 10th, that's applying the product rule. And so we add the exponent, so that's x to the 14th. And then we have y to the 6th, and y to the 5th. So we get y to the 11th, and then we can bring down the z squared. Okay. And so this is your answer. All right. Okay, that would be the same. All right, here we are using the area of a rectangle, right, to find the area of this rectangle. So basically, length times width, area is equal to length times width, and we have 2x squared times 5x to the 4. So we just finished dealing with this. So basically, what do you get? 2 times 5 is 10. And then x squared times x to the 4th is x to the 6th because you add the exponents. So the area is 10x to the 6th. All right, so the last portion is just of this section. It's just multiplying, okay? So multiplying. So you want to be careful with your negatives, all right? And so here, just basically distribute the negative 6x squared. So when you distribute, I'm doing a negative times a negative, okay? That's a positive. 12x to the 4th because you add the exponents. Negative times this positive is negative. Negative 6x, and this is a 1, so you add them, so that goes up to a 3. And then a negative times a negative is positive 30, and just tag the x squared along. And that's it. You have no like terms to add or subtract. Okay, that's your final answer. All right, multiplying. Okay, we'll do this one right here. All right, because this one gets people. So basically, what does this mean when you have 5x plus 3 quantity squared? It means you see it twice. So you need to write it out twice. Okay, so this is a binomial times a binomial. Normally you can use the full property, okay, which is just nothing more than the distributive property. So basically start with the first one and distribute that to these two, right? So 5x times 5x, you get what, 25x squared, and then 5x times positive 3, you get 15x. Then you do the same thing with the positive 3. So we're going to distribute this to both terms. 3 times 5x gives you plus 15x, and then 3 times 3 gives you plus 9. So we've covered everybody, okay? 5x has been with these two, 3 has been with those two. All right, so now we have to combine like terms. We have 15x and 15x, which gives you 30x. So when you bring down the 25x squared, combine like terms, bring down the 9. And this is your answer. And so that pretty much deals with the multiplication part. So you are, the beginning part of this, you find the degree. Let me just go back over that just in case you missed it in class. All right, so we dealt with the coefficient and the exponent. Coefficient here is 9, exponent is 6. Okay. And we have, if we look at the base, if we're talking about base, we have two bases, 9 and 6. Dealing with the degree, again, we look at the variable part. Okay, in this case, you won't have they won't give you more than one term. So you don't have to look at each individual term to see who has the highest degree, because the highest degree wins. All right, so in this case, we look at the exponent of the variable, okay? And so that's why the degree of this term is 3. And then evaluating, you know how fx is 1, plug it in, follow your order of operations to simplify it. And then you get into the, that's more evaluation, the subtraction. So just be careful with the subtraction again. When you're subtracting, if you have 3n to the 4 plus 4n minus negative 4n to the 4th minus 7n plus 6. Again, there's a positive 1 here, but there's a negative 1 in front of this one. When you distribute a positive 1, it does not affect the signs of the terms. However, when you distribute the negative 1, it affects the signs. So that becomes a positive 4n to the 4th, a positive 7n, and a negative 6. So that part you need to get. Then you can combine your like terms, okay? 3n to the 4th and 4n to the 4th. That gives you 7n to the 4th. Again, the exponents do not change. And then you have a positive 4n and a positive 7n. You get 11n. And then we can bring down the minus 6. And that is it. Okay, adding, subtracting polynomials. So that's for the first part. Okay, and then we'll move on to more of the laws of the exponents in the second set. Okay, if you have any questions, please let me know.